Hello, everyone. Welcome to today's session on Office 365 mail flow. My name is Ajay. I'm a support escalation engineer in the Office 365 support team. And with me, I have Vishnu. Vishnu?
Hello everyone, my name is Vishnu. I'm also one of the support escalation engineer here at Microsoft.
All right. So our objective for today's session is to talk about how mail flow works in Office 365 and also discuss the different tools that we have to troubleshoot mail flow issues. The information we present in this session should help resolve most of the common mail flow issues. And in case a support ticket needs to be opened, the information from this session should help our customers to collect the relevant data to attach with the ticket, which helps us resolve the tickets quickly. Here's the agenda for today's session. We start with the basics of mail flow, both how it looks like internally within the organization, as well as for emails sent externally over to the internet. We then talk about the transport components that are involved in mail flow, followed by a discussion on hybrid mail flow, which is basically mail flow when you have an on-premise Exchange environment and also an Office 365 tenant. We briefly discuss the architecture of Exchange Online Protection, how it receives and scans messages for anti-spam, anti-malware. We then have a short discussion on enhanced filtering for connectors, which is a fairly new feature that was added based on the difficulties we were seeing in certain complex mail scenarios where customers are using third-party services before the message is delivered to Exchange Online. So we'll discuss that in detail in the upcoming slide. We also talk about how to relay mails through Office 365. There are genuine business reasons to relay messages from Office 365, and we discuss the three options available to us for mail relay. And finally, we talk about the tools that we use to troubleshoot mail flow issues and a few common scenarios that we come across when we work on cases in the support team. So we'll start with the basic mail flow. In any email communication, we have mail clients, which are the user interface to access emails. And then we also have mail servers. So mail clients, common ones would be Outlook. We've got Mozilla, Thunderbird, and the most common one can be just a web browser. So these are the mail clients that users see when they want to access the mails. And then on the back end, we have email servers like Exchange, Exchange Online, Office 365, and free third-party services like Gmail, Yahoo, Hotmail. When we have a client, we also need a way for the client to connect to the server. So email clients connect to the Exchange server or the mail server using well-known protocols. We have a few old protocols such as POP3 and IMAP. And then we have the more recent ones like MAPI, HTTP, EWS, ActiveSync. So these are the clients that the protocols that a client uses to access emails on the server. For every protocol, we have a specific port to connect to the server. For example, POP3 works on port 110, IMAP works on port 143, and then we have the other more modern protocols like MAPI, HTTP, which Outlook uses, EWS, ActiveSync, which only work on port 443, which is the HTTPS port. The move is towards using HTTPS primarily because it is a port which is by default open in most enterprise environments. And moreover, it is more robust in terms of handling the data as compared to the older protocols such as POP3 and IMAP. Coming to the ports, the protocols that the clients use, protocols like POP3 and IMAP, they're used for downloading messages from the server. So these are unidirectional protocols, and POP3 and IMAP only is used to download messages from the mail server over to the client. And then the clients which use POP3 and IMAP, they send messages to the mail server using the standard SMTP protocol. Clients that use MAPI HTTP, ActiveSync, HTTPS, these all use the same protocol for both sending and receiving. So unlike the old protocols where one protocol is used to download messages and another protocol is used to send messages, HTTPS based protocols use the same protocol for sending and receiving. Once the message is on the server has to either deliver the message to a mailbox hosted locally, or it has to be sent over the internet to another server, which eventually delivers the message to the recipient's mailbox. This server-to-server communication happens using the standard SMTP protocol. In Mailflow, we also have other optional services such as anti-malware and anti-spam services like Exchange Online protection. In Exchange Online, we also have Exchange Online advanced threat protection. We also have scenarios where message encryption and decryption would be needed, rights management, another security option. So these are optional components which also integrate with the Mailflow. But again, it depends upon the requirement and the scenario where these get involved. But we do have all of these services in Office 365. On this slide, we just want to show the overview of how mail flows from a client user 1, which is in domain a.com, to another user 2 in a domain over the internet, domain b.com, how the flow would look like. And again, it's a very broad overview of how things work, but we just wanted to picture it here so that the understanding is clear. So when a user in a.com, user 1, wants to send emails to user 2, the user has to establish a connection with the mail server. And as I mentioned earlier, these could be any of these protocols. So it could be using SMTP protocol to send messages over to the mail server, or the client could be using Outlook, which uses HTTPS. So with that, when the user clicks on send, one of these protocols is used, and the message eventually makes its way to the user's mail server. Once the mail server receives the message and sees that the message is for a user 2 at b.com domain, the server needs to determine how to transfer this message to the mail server of b.com. And to do that, the sender's mail server queries DNS asking for the MX record for the domain b.com. It gets a response from the DNS with the IP address for b.com's mail server. Once a.com's mail server has the IP address, a.com's mail server connects to that IP address using port 25 to establish the connection. Then it transfers a few SMTP commands, and eventually, with the data command, the message is transferred from a.com to the server on b.com. Once the server receives the message, user 2 at b.com simply accesses the message using either of the protocols that are listed here. So if it's using an old client, it would use POP or IMAP to download the message. And if it's using Outlook, it just accesses the message using HTTPS. And that's how this transaction completes from user1 at a.com to a mail sent to user2 at b.com. Now we look at how mail flow happens in an exchange environment. So in the previous slide, it was a very generic overview of mail flow. In this slide, we look at the specifics of how mail flow happens in exchange in an exchange environment, which is also true for Exchange Online. So Exchange Online works in a similar fashion as we are showing here for an on-premise Exchange environment. So I'll quickly explain the services involved here. At the top of the picture here, we have the front-end transport service on the Exchange mailbox server. The front-end transport service is mainly responsible for accepting messages from another Exchange server. It could be an external server on the internet or another Exchange server within the same organization. All it does is it accepts the messages from the server, and then it transfers it to the transport service on the server. Now the transport service, which is the middle section of the picture, that service is responsible for doing the routing, the categorization, and to also look at the message content and take action on it. So this is the service responsible for understanding how the message needs to be routed to the mailbox of the user. And in that process, the transport service also carries other functions like, does it need to create a copy of this message for journaling purposes? Does it need to inspect the message and see whether the message has content which might be something that the administrator wants to block? So all those functions take place on the transport service of the mailbox server in Exchange. Once this has been done, the transport service knows that it needs to transfer the message to the mailbox transport service, which can be locally on the same server or could be the mailbox transport service on another Exchange server. So the mailbox transport service has two subcomponents: the mailbox transport submission service and the mailbox transport delivery service. The names are kind of confusing, but the mailbox transport submission service is a service which is responsible to pick up emails submitted by the local user, which is supposed to be sent to another user. So the transport submission service is basically responsible for picking up emails from the mailbox and deliver it to the transport service to get it routed. And the mailbox transport delivery service is a service which receives the message from the routing, which is the transport service, and delivers it to the mailbox. So these are the functions of the mailbox transport submission service and the mailbox transport delivery service. We'll take a look at how mail flow happens between two users which are on the same mailbox server of Exchange. So here's how it looks like. So you've got a user sending an email to another user on the same Exchange server. So once the user sends the message, a notification is generated, and the mailbox transport submission service picks up that notification and knows that there's a new message that needs to be routed. So it picks up the message and it sends over the message to the transport service for the transport service to determine what route the message is supposed to take to reach to the recipient. The transport service looks at the message in the categorization phase. It knows that the message is destined for a user hosted on the same Exchange server. So once the categorization is done, the message is either sent to another mailbox server if it is not on the local, if the recipient is not on the local mailbox server. In our case, the recipient exists on the same server, so the message is routed back to the mailbox transport delivery service. The mailbox transport delivery service receives the message from the transport service, and eventually it delivers the message to the user's mailbox. So this is how the message flows between two users on the same Exchange server. Now let's look at how an incoming message is handled by Exchange. So we've got an incoming message coming in from the internet. Over here, what we have an additional layer, which is the edge transport server. So in Exchange, we've got the edge transport server role, which is basically a role which resides on the perimeter network. So if there are a lot of corporate customers who do not want to expose their Exchange server directly on the internet, so we've got the edge transport role, which can reside in the perimeter with very limited access to other resources on the network. So it uses the read only for Active Directory to fetch directory information, and that's how it is more secured to have an edge transport server. So some organizations have edge transport roles. So in this picture, we show that we have an edge transport server which actually receives a message from the internet. Once it gets the message, the edge transport server simply forwards the message to the front-end transport service on the mailbox server. And the same process takes place after that. So the front-end transport service simply hands over the message to the transport service on the mailbox server. The transport service will do the categorization and figure out what is the ultimate destination for this particular message. Once it determines which mailbox server holds the mailbox for this user, it transfers the message to the mailbox transport delivery service, which eventually delivers the message to the user's mailbox. Here we show how an outgoing message is handled. Again, in this scenario, we have the edge transport server in picture, but even if it was not there, the mailbox transport server can directly route messages to the internet. So here's how it looks like. Once a message is sent by the user, the mailbox transport submission service gets the message. It forwards the message to the transport service for routing. The transport service in turn sends the message over to the edge transport server to be sent outside the organization to the internet. Let's look at the transport components in an Exchange Online and Exchange on-prem environment. So there are several components involved when we try to route messages, and these play an important part in not just routing the messages, but knowing what these components are is also important when we are troubleshooting issues with mail flow. So here are the main components that we're going to discuss. We've got accepted and remote domains, and we've got a slide on each of these coming forward. So we've got accepted and remote domains, we've got connectors, then we've got transport rules, and then we also have anti-malware, anti-spam scanning. So let's look at each of these in detail. Accepted domains. Accepted domains can be looked at when we troubleshoot mail delivery issues, issues where emails are failing with recipient not found errors for a newly created on-premise mailbox or mail-enabled public folder. So what are accepted domains? Accepted domains are domains which the organization owns. These are also accepted domains are also known as the address spaces. Okay, and we configure the accepted domains in an Exchange organization to receive email messages. Accepted domains consist of the following types. We've got authoritative domains, domains that we accept emails from the internet, And we are also responsible to generate the non-delivery report in case the message cannot be delivered to the mailbox. So those are called the authoritative domains. Then we have relay domains. Relay domains, again, are messages that we accept emails for. So we have a domain, we will accept the message for that domain, but the exchange server is not responsible for generating the non-delivery report in case there's a failure. So these are relay domains. Relay domains can be a domain that we own, or it could be an external domain that we don't own, and we simply route messages to that specific domain. We use accepted domains to set up the email addresses on the user. So when we create a mailbox, every mailbox gets an email address. The email address is getting stamped on the user using the email address policies. So email address policies stamp the users with the SMTP addresses which belong to the accepted domains in your environment. How do we manage accepted domains? We can use the portal and we can see the accepted domains section there. And we can manage the accepted domains from the portal using the UI, or we also have an option to manage the accepted domains using PowerShell with the get-accepted domains and set-accepted domain PowerShell commandlets. The next type of domains that we have are remote domains. Remote domains are used to control the information that goes out of your organization. So it's basically used to control how much information goes out of the organization. Examples of this would be your automatic replies and automatic forwards, out of office replies, delivery reports and non-delivery reports, meeting forward notifications. Remote domains are also used to specify message formats. So messages have a format. If we look at it from a client perspective, a message can be a plain text message, it can be a rich text message, or an HTML message. So the clients usually manage this for the users, but we also have these settings in the Exchange environment to control how messages are transmitted to external hosts. So these are the different formats that the server supports and can be set using remote domains. The format of a message primarily is controlled at the client level. So the user has the option to select how the message should be displayed and how the message should be sent out using the client configuration option. Outlook and OVA clients by default determine the format of email messages and how they are sent to the recipients. However, whatever settings we have at the remote domain level, it supersedes the settings at the user level. So basically, remote domain level settings at the organization level have precedence over user-specific settings which are in the client. Again, for remote domains, we have the admin portal where we can manage the remote domain settings using the UI, or using PowerShell, we can use the get-remote domain and set-remote domain commands. Next, we look at connectors. What are connectors? Connectors is basically a collection of instructions that we provide to the mail server, in our case, Office 365, on how to route the message. So if we want to route messages to an environment, to an external environment, we need connectors. So that's what connectors do. They basically have an address space. So connectors basically tell Exchange how to route message to an external environment. There are three types of connectors in Exchange Online: on-premise connectors, partner connectors, and then we have criteria-based connectors as well. And we'll talk about each of them over here. So what is the on-premise connector type? On-premise connector type is usually used when we have customers with on-premise Exchange servers, and they also have an Exchange Online tenant. And we want to configure mail between online and the on-premise environment. We use the on-premise connector type. The purpose of using on-premise connectors is basically to make the two separate environments function as one single Exchange organization. So that's what on-premise connectors are used for. We have certificates that are used to secure the messages when we're using on-premise connectors. When we do a hybrid setup using the hybrid configuration wizard, the connectors are set up by the wizard, and the certificate is also selected in the process of setting up hybrid. On-premise connectors with IP address should only contain IP addresses owned by the customer. That's the whole idea of having an on-premise. On-premise connector means a connector to a server which we own, and that's why we should make sure that if we are adding IP addresses to the connector, it should always be the customer's own IP addresses. We also have certificates which are configured when we run the hybrid configuration wizard, and we have to ensure that the certificate is set up correctly, has the right domain names, and other details, is valid as a third-party certificate when we are setting up the on-premise connector. If there is a certificate mismatch, one of the common scenarios that we have seen working on cases in Office 365 is we get a relay access denied error message. When we receive emails, when Office 365 receives emails from an on-premise environment over the connector. So it's important to ensure that the IP address and the certificates details match on both the sides, that is on the on-premise as well as in the Office 365 side. In on-premise connectors, we also have an option to enable centralized mail routing. Centralized mail routing basically is a setup which is not used very commonly, but is required in certain compliance requirements. So some organizations have a requirement that they want to journal everything that comes, and they are in a hybrid setup. So what does centralized mail routing do? It's just an attribute that we set on the connector, which says route all mails via on-premise. So when Exchange Online receives any email, even if the mail is supposed to be delivered to a mailbox in Office 365, Exchange will not deliver the message, but instead route the message to the on-premise environment, so that the compliance requirements are fulfilled. So if the customers have a compliance requirement to capture every email that comes into their organization, and that's in the on-premise environment, so this particular setting allows us to route all incoming messages first to the Exchange from the Exchange Online environment to the on-premise server, and then the message comes back and eventually gets delivered to Office 365. Centralized mail transport can only be configured using PowerShell, okay, and should only be used if there is a specific compliance requirement. Otherwise, it simply adds more complexity in the mail routing. Here's how an on-premise connector setup would look like. So we've got the on-premise environment here, and the important part is the domain. So we've got mailboxes for the same domain hosted on-premise as well as in Office 365, and we've got connectors for each. The important point is connectors are unidirectional. So we've got a connector both for inbound mails, and then we've got a separate connector to send mails out. Our inbound connector is basically to receive emails from an external source, and the outbound connector is a connector which routes emails out from the environment. So we've got these two connectors. Usually these connectors would be created by the hybrid wizard when we run the hybrid configuration wizard, but can be created manually as well. So this is how it looks like. So that's the on-premise connector type. Let's move on to the next one. We also have the partner connector types. Partner connector is a connector that is used to have a special configuration when probably communicating with a specific partner. So as an Office 365 tenant, you may have a business requirement with an external organization, but the requirement is to make sure that the mail flow happens only with a specific IP address, or it happens using force TLS. So in these type of scenarios, when you want to have some restrictions on how mail is transmitted between your organization and an external third party, we use a partner connector type. As we see, it's needed primarily for security restrictions between mail exchanges with a partner organization or service provider. We've seen a lot of customers use partner connectors because they have third-party services like for archiving, anti-spam filtering. And again, partner connectors are completely optional. These are not required unless we have a specific requirement of either sending messages to a specific IP address or to secure the transmission of messages between our organization and the external organization using force TLS. Those are scenarios when we use partner connectors. This is how it would be when it comes to partner connectors. Here, what we're trying to show is we're trying to use forced TLS between the Office 365 environment on the right and the external partner, which is contosobank.com, using a partner connector. We have another form of connectors which are criteria-based connectors. These are used for routing messages which match a specific condition. So when the requirement is that there's a specific condition, if a message qualifies that condition, the message should be routed somewhere. We use conditional mail routing, and these connectors always have a transport rule associated with them. So essentially, it's a combination of a transport rule and a connector. And what it does is, if a message qualifies with those conditions that we set on the transport rule, the message will be routed through that specific connector. Again, there's always going to be a transport rule, and these are the scenarios in which we use conditional mail routing. If we have third-party archiving, journaling services, we use conditional mail routing. We also have scenarios where we use it for adding signature, adding disclaimers to emails going out. These are scenarios when we use criteria-based routing. Let's look at what are transport rules. Transport rules act on messages in transit within the exchange organization. These are not to be confused with mailbox rules, which basically act on messages once the message has been delivered to the mailbox. So we've got transport rules which act on messages which are in transit, and then we've got mailbox rules which apply on messages that have been delivered to the user mailbox. Transport rules are made of conditions, exceptions, actions, and provide us with the flexibility to implement many different types of messaging policies. And we'll see a few examples of those over here. What are the conditions? So conditions identify the message that we want to apply the actions to. So every transport rule has a condition, and we want to take action for messages that have that condition. So conditions basically identify the messages that you want to apply the transport rule action on. Some conditions examine message headers. For example, you want to look at the who sent the message, like the to field or from field, or who's CC'd on the message. Other conditions examine message properties, such as message body, the subject of the message size, uh, whether the message has an attachment or not. So these are different conditions that we can look at. Most conditions require specifying some sort of a comparison operator, uh, where we match a value and to a condition, and if a message qualifies that particular setting, then the rule gets applied to it. So those are the conditions. Then we have exceptions. Exceptions are the conditions where you want a transport rule to skip a message. Again, it's just the opposite. So if we have a transport rule which acts on a certain type of messages, we also want to have exceptions. So let's say if you are taking action on messages with an attachment, but we can set an exception, maybe for someone who's maybe the CEO of the organization. So if you want to have exceptions to the transport rule, this is where we specify the exceptions. Then we have actions. Actions tell the transport rule what's supposed to be done with the message. So actions basically specify what to do with messages that match the condition and don't match the exception. So that's what the actions specify. There are many actions available in a transport rule, uh, such as rejecting the message, deleting the message, or redirecting the message uh, to additional recipients, adding prefixes to the messages, uh, maybe modifying the subject of the message, or adding disclaimers to the message. So these are the actions that can be added to the action section of a transport rule. And then we have properties of transport rules, properties which talk about the transport rule settings that are not conditions, exceptions, and actions. These can be, for example, whether a rule should be applied, whether to enforce a rule, or we are just testing the rule. These are the common properties of a transport rule. Let's look at how transport rules are applied. So every message that comes into the Exchange environment, or Office 365 for that matter, they flow through your organization and they're evaluated against any existing transport rules that we have created. So rules are processed in the order they were created. Rules that were created first have the highest priority, and as we keep on adding rules, the newer rules have got lower priority. We can look at the order of the rules in the Exchange admin center, and they're ordered in the way they are created. So the rule which is right on the top has the highest priority, and as we keep adding rules, we have rules with lower priority. We can also use PowerShell to check what the priority of a certain rule is. Once we have a message coming in into the organization, each rule is evaluated against the message, and on every transport rule, we have an option to either stop processing more rules after it when the message has been evaluated, or continue evaluating the other transport rules. So that's a setting on every transport rule, whether you want to evaluate further rules below the priority, or you want to stop with the evaluation of the message at this specific transport rule. Here are the common scenarios when we use transport rules. We use transport rules when we want to have organization-wide disclaimers, signatures, footers, uh, headers in Exchange Online. We can create organization-wide safe and blocked sender lists. So if these are common scenarios. So if you have a email coming in from an external host with a specific email address, we can have a block list or a safe sender list, and we can use transport rules for that. We can use transport rules to scan messages with certain phrases, patterns, words, and take action on those messages. We can have transport rules which can be used to bypass the clutter option in Exchange Online. So we've got transport rules for that. We can have transport rules to set the SCL value on messages. SCL is basically the spam confidence level. For internal messages, the SCL value is always 1 or -1, and for messages received from outside, the SCL value is calculated based on how the message was scanned and what's the content of the message and from where we received the message. So we can use transport rules to manipulate the SCL values of messages as well. We can have transport rules to inspect messages with attachments in Office 365. So as I mentioned, it's a very flexible way of taking action on messages based on what conditions we are looking for, and transport rule allows us to do that. Let's look at hybrid mail flow. A hybrid mail flow is only a setup which is seen when you have an on-premise environment and Exchange Online environment, and we want to make the two organizations work as one single Exchange organization. We set up hybrid mail flow as part of the hybrid configuration wizard. So when we run HCW, HCW will configure the connectors for us. It will select the right certificates for us, and essentially it will ensure that the mails between these two environments, that is the on-premise environment and Office 365, appear as internal to all Exchange components, be it the on-premise environment or the Exchange Online environment. Essentially, the users and even the Exchange components do not differentiate for a message coming from on-premise to Exchange Online or vice versa to be coming from a different source, but it is considered to be an internal message. And again, this is important in a hybrid environment, because there are cases where a message is received from the on-premise environment, but we see that it is going into the junk mail folder of the cloud mailbox. Or we've seen scenarios where messages from on-premise, we do not see the display name of the sender, and instead only see the email address. So these, if we have the settings right, and if we use the hybrid configuration wizard and selected the right options, the message will show exactly how it would for two users in the same organization. When we run the hybrid configuration wizard, a part of hybrid mail flow is to also make a decision on how we want to accept messages coming from the internet. So external messages, how we want to accept it, whether we want to accept it on premise or we want to accept it through Exchange Online, that decision is also made on while we run the hybrid configuration wizard. And this is how it looks like. In this picture, we're showing an organization which is in a hybrid setup, and we have decided to accept internet messages coming from the internet first in the Exchange Online environment. Again, we control the receiving of external messages using the MX record. So wherever the MX record points to is where the message will be delivered, and this is how the setup would look like. So we are receiving an email for a user, Julie, and we have David CC'd on the message. David has the mailbox in Exchange Online, whereas Julie has a mailbox in the on-premise environment. So when we receive the message, because it is a hybrid setup, we deliver a message to David's mailbox in cloud itself. And for Julie, we route it to the on-premise environment using the on-premise connector type, which were created by the hybrid configuration wizard. Let's take a quick look at how Exchange Online Protection looks like and how the filtering happens when Exchange Online Protection receives a message from the internet. So when we are receiving an email for a tenant hosted in Exchange Online, the message will always be delivered to a specific set of Exchange Online Protection data centers and IP addresses, which is allocated at the time when the customer signs up for Office 365. So email will always get routed to that specific data center when an email is sent to an Office 365 mailbox. Once the message is received, the message is then scanned for IP block list, URL block list. So in Office 365, we utilize two block lists at all times. One of them is maintained by Spamhaus, and the other one is our own internal block list, which we use to evaluate the reputation of the sender. The block list is where we try to eliminate most of the unwanted messages, and that's where most of the decisions are taken, whether a message should be let in or should be sent to junk. Those kind of decisions are done at this phase. We also have a recommendation, and this has been the recommendation right from the time we have Office 365, that is not to host any other service before Exchange Online Protection. And the reason is this: we look at the IP addresses and other properties of the message to determine whether this is a message from a good source or a bad source. Now, if we have another service before Exchange Online Protection, from a service standpoint, Exchange Online Protection only sees messages coming from that service's IP address. And in that case, it's very difficult for Exchange Online Protection to determine whether this message has to be classified as as clean, or it should be classified as malicious, because the IP, the service before Exchange Online Protection, it just obfuscates the original IP from which the message is coming from. And for this specific reason, we eventually came up with the enhanced filtering option that we'll be discussing in an upcoming slide to get around this problem. Because initially, before this, if we were receiving the email from the internet, we would see the source IP address, and then we were able to determine the reputation of the IP and do all the other checks. But when we have a third-party service or another layer in between Exchange Online Protection and the internet, that's where things were getting difficult. That's what we'll be discussing, that feature, the enhanced filtering, in an upcoming slide. But here's where we do all the filtering. If at all we block any message because of the reputation of an IP address, NDR is generated to the sender stating that they are on a block list, and the NDR usually contains information on how to get themselves delisted as well. Once this phase is over of checking the reputation of the sender, we have the virus scanning. At any point of time, we use 3 anti-malware engines to scan messages. And one of those anti-malware engines is the Microsoft engine. And then we've got other partners whose engines we use for scanning messages. So every message will scan by 3 anti-malware engines. If the message is clean, doesn't have any malware, it moves forward. And if it is not clean, it gets quarantined. If the message is clean, we go to the next phase of scanning, which is the policy enforcement phase. This is a phase where the message will be subjected to the customer's transport rules, okay, and action is taken based on the transport rules. Once this phase is over, message goes on to the spam protection phase. At the spam filtering layer, messages are evaluated against bulk mail filtering based on the characteristics of the message. We also do the safe list as the safe sender and block sender evaluation here. And then we also have additional admin level settings such as advanced spam filtering done in this particular phase. So if the message clears this phase, it moves forward to be delivered to the mailbox. If it doesn't clear this phase, the message will be delivered to the user's junk mail, and then the users have the option to report it as a false positive. In some cases, it can be a false negative as well, which our spam analysts will review and make adjustments to the rules with which the message was evaluated. So if the rule needs adjustment, this is where it is done. And that's why it is very important whenever users get a false positive or a false negative, it should always be reported to Microsoft using the option in Outlook so that the rules can be adjusted. Let's look at how Exchange Online Protection manages outbound messages. So it's pretty much the opposite of the incoming. So we receive the message either from the on-premise environment or from a mailbox in Office 365. We scan the message for malware, and if the message is clean, it moves forward. Otherwise, the message is quarantined. Then we evaluate the message for transport rules. If there's a rule to encrypt the message, all those evaluations happen here, and the message moves forward, where we check the message for whether the content of the message to determine whether the message is clean or has potentially risky content, which might make the message be marked as spam by an external host. So we do that scanning in the spam protection phase. If the message is clean based on the rules, we route the messages to a regular pool of IPs. Now we've got two set of IP pools. One is the regular IP pool for outbound messages, which we use for all messages which have a low spam score. And then we also have the high risk delivery pool. Now these are a set of IP addresses which are more or less going to be blocklisted, in external block lists. So these IPs have bad reputation, and we purposely have these set of IPs which we use to send out mails which may be potentially spam. So those type of messages are routed through the high-risk delivery pool. This basically is a mechanism to protect our service, where we don't want all the customers to get impacted because of malicious content or maybe spams being sent out by one tenant. So if we classify the message to have high spam score, we route them through high-risk delivery pool, and the message goes out through that. Otherwise, it goes out through the regular outbound pool, which are IP addresses which are not listed on any external blacklist. Let's look at the anti-spam and anti-malware filtering. So Office 365 has built-in malware and spam filtering capabilities. Admins do not have to take any additional step to configure these. These are enabled by default. Anti-spam filtering has multiple components in it. So one of that is connection filtering. Connection filtering is where, when we receive emails from an external host, we try to check the reputation of the sender, the sending IP, and make decisions of that sort. And then we also have spam filtering. Spam filtering is the phase where we look at the content of the message, look at the characteristics of the message, and make a decision whether the message should be classified as spam or it should be classified as regular email. Spam filtering there are a few options that admins can control in spam filtering. So Office 365 checks the characteristics of the message consistent with spam and using spam filtering. Advanced spam filtering is an admin option which is used to aggressively scan the message based on the source of the message, based on the language of the message. So these are the settings that the admin of the tenant can review and modify, and that's what comes under spam filtering. Additionally, we also have end user spam notifications configured under spam filtering. So in spam filtering, we have an option where if a message is marked as spam and it is probably sent to the quarantine of the user based on how the admin has configured the spam policies, we also generate a notification to the end user, letting the user know that there's a message was classified as spam and was sent to quarantine. So that is done here. Then we have mail for rules for custom requirements. Again, these are mail for rules which might be used to set a SCL value or for messages coming from a certain sender or from a certain IPs. That comes under anti-spam filtering. And anti-spam filtering also uses email authentication to understand the source and to prevent spoofing of customer domains. So the three main technologies that are used are SPF, DKIM, and DMARC. SPF is Sender Protection Framework, where we try to evaluate the reputation of an IP to see if this IP is known to send spam messages. DKIM is basically an option where a sender can write or stamp the message with a signature, which kind of proves the sender of the message. That's what DKIM does. And DMARC is a technology where the sender is telling the recipient what action to take on a message which fails the SPF or DKIM. So these are technologies that come under anti-spam filtering, which help us determine what action should be taken on a specific message. And then we also have end user allowed and block sender lists that are evaluated in the anti-spam filtering phase. Anti-malware filtering, again, we use minimum three anti-malware engines to scan every message that comes in or goes out of the environment, Exchange Online environment. So the reason is we've seen the best results with using multiple scan engines than just using one. So one of them is Microsoft. The other advantage of having multiple engines is that there's a real-time threat response. So if any one of those engines finds content which is malicious, the service gets updated with the definitions, and all the tenants in the Office 365 environment get updated with the new definitions. By the way, the definitions are pushed every 2 hours to the service. Now let's look at enhanced filtering for connectors. So as I mentioned earlier, there are certain scenarios in some environments where we do have a service between Exchange Online protection and the original source of the message. So customers have requirements where they have third-party filtering services that they already have been using, and they also have users in Exchange Online. So in these scenarios, messages that come into the environment for Exchange Online, they seem to be coming from the same set of IP addresses, and this causes problem because when we look at the source of the message, we look at the IP address, and we always see the source of the message to be that third-party service. So we have these scenarios where customers were using a third-party service before Exchange Online Protection. That was causing a lot of false positives and false negatives for the messages which were ultimately delivered to the user. So these are the common three scenarios. We've got third-party cloud filtering services that customers might be using, and now they are moving to Exchange Online. But in the interim, they want to use their third-party service along with Exchange Online. Then we could have a managed filtering appliances for journaling and other purposes. And we also have scenarios where you've got the hybrid environment, and we have pointed the MX record to the on-premise environment instead of updating it to Exchange Online. So the recommendation for Office 365 is to always point the MX to Exchange Online protection rather than to have it on to anywhere else. But again, because there could be requirements where we want to route all messages to the on-premise environment and then deliver it to mailboxes in Office 365. MX can be pointed to on-prem. Now, in these cases, every message that is coming from any domain on the internet, from a source standpoint, Exchange Online sees that message only coming from the customer's IP address for the on-premise environment. So this is how it looks like. So if a sender is sending a message from the IP address 192.168.1.15, and we have a third party or the on-premise environment in between with the IP address of 172.17.17.35, for Office 365, the sender of that message is the IP address 172.17.17.35. This is the scenario where we do not have enhanced filtering for connectors enabled, and this was how it was before we had this feature. With enhanced filtering for connectors, what we have done is there's an option in enhanced filtering for connectors to skip IP addresses. So essentially, what it does is we have an option to skip certain IP addresses so that the health check can be done to the real source of the email or the sending IP address of the email rather than the last IP address that we received the message from. So when we enable enhanced filtering for connectors, we do see the benefits where we would actually be able to do the right analysis on the source of the message and take the right actions. So that basically improves the overall experience from an end user standpoint, where you can expect to have less false positives or false negatives because the health check was done against the real source of the message rather than the message which is getting routed through a service or through on-premise. As again, enhanced filtering for connectors allows us with the ability to use explicit email authentication mechanism like SPF, DKIM, and DMARC, and to get the reputation of the sending domain for spoof. And with enhanced filtering for connectors, this is how the flow would look like. So here we have the same scenario. The sender is sending from 192.168.1.15, which was then delivered to 172.17.17.35, which could be your on-prem environment or a third party. But when we received the message in Office 365, because of this particular feature, we are able to see the original sender of the message, which is the IP 192.168.1.15. So enhanced filtering for connectors is part of the Security and Compliance Center, and we can access it directly using the link which is on the slide. We can also control this feature using the set-inbound connector command and using the specific parameters like the EF skip last IP, EF skip IPs, and EF users. What these mean, so the skip last IP, if we set this to true, when we receive the message, Exchange Online Protection will just ignore the last IP and do the health check against the second last IP address in the message header. But we also have an option to skip multiple IPs. So if we know that there are multiple hops that the message takes, and a few of those hops are trusted environments, and we want to skip checking doing health check against those IPs, then we can add those IPs under this parameter, which is EF skip IPs, where it's basically a comma separated list of IP addresses that we want to skip, and then do the IP health check. And then we have the option for EF users. EF users, you have the option to use this feature at least when if it's something new that we are that's being set up in the tenant, to maybe just use it for a specific set of users. And if you want to do that, we would specify the email addresses under EF users. And if we set this attribute to null, basically what that means is that the enhanced filtering is enabled for every user in the tenant. And this is how the UI looks like for enhanced filtering. Coming to the Office 365 mail relay, there are three types of mail relay options in Office 365. We've got client submission. In client submission, we have probably an on-premise service device or a line of business application that wants to send emails to the mailboxes in your tenant in Office 365, or even to external recipients. In that case, we have the client submission, SMTP client submission option. This option essentially is like you having a mailbox, a licensed mailbox in Office 365, and works more or less like a real user sending an email out. So with SMTP client submission, all the regular limits that applies to any normal user, that is the number of emails that can be sent in an hour, the total number of emails, those limits apply to SMTP client submission. So SMTP client submission is the easiest to set up, but it requires a license, but it allows you to send emails to your own cloud users as well as emails outside to external domains. Then we have another option called direct send to relay messages through Office 365. In direct send, we do not have to have a provisioned mailbox in Office 365 and use those credentials to relay messages through Office 365. With direct send, we send emails using a specific host name. We send emails to that host name, and Office 365 delivers it to the recipients. The difference between direct send and client SMTP submission is with direct send, we can only send messages to the mailboxes within our own tenant. The messages cannot be routed out. So if the business requirement is only to send maybe messages from a scanner or printer to your internal users whose mailboxes are in Office 365, direct send is the best option, because there's no need to even have a mailbox and use a license to use this method. Then we have SMTP relay. SMTP relay is an option where we create a connector in Office 365 and we route messages through Office 365 using the connector. The SMTP relay is the most flexible option of relaying. The limits are much higher. The limits on how many emails can be sent, those limits are much higher with SMTP relay and most restrictive for SMTP client submission. So if we want to send more than the usual volume of emails to internal users or even to external users, SMTP relay is the method. This method is slightly complex because we need to have the IP addresses that would be used in the on-premise environment to send messages to Office 365. So we need to know the IP address that we're going to receive emails from. And in Office 365, we need to have a connector which has those source IP addresses or the TLS certificate to prove that the message is coming from a source which is allowed to relay through the tenant. And This particular method has no restrictions on just sending it to internal recipients or external. You can send with this method to internal Office 365 mailboxes and also to external domains. This has the highest flexibility in terms of the volume of messages that can go through. So that's the third method of SMTP relay in Office 365. And on this slide, we just summarize the differences between the three methods. And as I mentioned earlier, SMTP client submission probably is the most restrictive in terms of how many messages can be sent out, the volume of messages, and the frequency of messages. And SMTP relay is the most broader way of sending messages out with less restrictions. So this table summarizes that, and we have a article published on each method on docs.microsoft. So pretty straightforward, and that concludes that. And with this, I come to the end of my session. The next few slides will be taken by Vishnu, which talks about deployment scenarios, tools, and the troubleshooting steps. Thank you.
Thank you, Ajay. All right, so let's get started. So we'll see what are the different methods, or how can we use EOP as a service or how can we use EOP as a standalone? How can we integrate EXO with on-premises, and how the routing take place? What are the different types of connectors that comes into play? So we saw what are the different types of connectors that we have. We'll see how that comes into play when we configure them in Office 365 for the mail profile. Now, first thing, we can have a fully hosted wherein there is no coexistence. All the mailboxes are in cloud. And when it comes to EXO, we have a hybrid setup where we are in a coexistence. We also can have a standalone Exchange Online protection wherein all your mailboxes are hosted in on-premises and EOP is used only for your protection purpose. And what methods to choose, it completely depends upon how you want to set up or how we want to utilize Office 365 services. So first we'll see the mail flow scenarios when we have a fully hosted environment. Then we'll look into having only EOP. Then we'll look into how the mail flow behaves or works when we have a hybrid scenario. And with hybrid, with centralized mail routing enabled. And when we have in hybrid, when we have the MX pointing to a service provider. So first we'll look into how a fully hosted environment. So it is Office 365. We have an external user, and we also have an partner domain or another Office 365 domain. First scenario, just give you a clarity, like you might see like all the emails are routed in and out of Office 365. It is kept intentionally just to show how all we can utilize Office 365 as a service. You might feel there are other ways of routing the email as well. Yes, it is true, but these slides are kept intentionally to see how we can completely utilize the inbound and outbound mail flow relying through Office 365. The first example, we'll see how it works or what are the components involved when a cloud user is sending an email to a different Office 365. So they use a outbound connector of type partner. If they need to have a dedicated routing, they can use a partner type connector to send that email. Else, we can also use a default outbound connector to send out that email to this particular domain. So just to rephrase, we have three types of connectors. One is your on-premises type connector. The two types of connector. One is your on-premises type connector, and other is your partner type connector. We use on-premises type connector only when we own the particular IP from where we are sending that email. And partner type connector when we know when we need to have a dedicated connector for sending emails to a specific destination. So first example is cloud user sending an email to a different cloud user. We can use an outbound connector of type partner. And second example, cloud user sending an email to external. So this can For this example, it doesn't require any outbound specific connector. It can use a default outbound connector to send out or to route the emails to the destination. Now, external user, when we are receiving an email from external to Office 365, it also doesn't require any specific configuration. It uses a default inbound type connector to receive those emails. Now, external to a different Office 365 domain, what happens is like since I said we are utilizing the EOP as a complete service, so we will be having an inbound type partner connector from which we'll receive the email from the external source or from the partner domain, and that email is then routed to a different location if we want to relay that email to. If not, the email is received on the Office 365 mailbox. Now, the second scenario is hybrid when we have an MX pointing to EOP. The same. The additional thing is we have an on-premises domain here. So first scenario is on-premises users when they try to send an email to yahoo.com. So the first is Office 365 receives that information from on-premises using the inbound connector of type on-premises. As I said, since we own this IP from where we are receiving these emails, we create the type connector type on-premises. And from Office 365, it is then routed to your MX or to your yahoo.com using the default outbound connector. There is no other. You can still configure connectors if you wish to, but by default, it just gets routed to your external source using the MX by querying the MX records. The second scenario, an external user, yahoo.com or any other third-party domain sending an email to your contoso.com for an on-premises mailbox. So the email is received to Office 365 first or to your Office EOP first, because your MX is pointing to EOP, and this again doesn't require any additional configuration. The email is received to Office 365, and using the outbound outbound connector of type on-premises. Using this connector, the email is relayed to on-premises mailbox. Scenario 3, on-premises mailbox trying to send an email to a different Office 365 domain. The email is again is routed to Office 365 using the inbound type. The Office 365 receives that information using this inbound connector type on-premises, and from there it uses an outbound connector type partner to a different Office 365 domain. Again, we need not need this. It automatically uses the default outbound. But if you have a requirement to have this type of connector, you can create this connector and route those emails using this connector. Now, the external Office 365 partner domain is trying to send an email to on-premises. Since the EOP, MX is pointing to EOP, the email is first received to Office 365, and using the outbound type on-premises connector, it is being routed to your on-premises environment. On-premises to cloud doesn't require any other configuration, since we already have the hybrid connectors, which is your inbound connector and outbound connector of on-premises. It uses that inbound. Office 365 uses the inbound connector type on-premises to receive that email, and the cloud to again it uses the outbound type connector of on-premises. The other next example is about a cloud mailbox trying to send an email to an Office 365 domain or a partner domain where no on-premises is involved. It uses the outbound type connector of type partner and routes that email. And same, if wants to send it to an external yahoo.com, it just uses the default outbound connector, which is inbuilt or it's been available within the tenant without any additional configuration. And external to cloud uses a default configuration. Now, external domain, sending an email to Office 365, it uses the inbound type of connector partner. So the whole intention of having this is to differentiate what connectors comes into play depending on where the transit is happening or between which entities the transition is happening. So moving on, the slides also will have the same type of examples. The only intention is to differentiate which connector is coming into play on what scenarios. So the same hybrid environment having an MX pointing to EOP, but the additional configuration that we see here is centralized mail transport or centralized mail routing enable, which means any email that is being routed uses the on-premises to get routed to an external. So we'll see how that works. So on-premises is trying to send an email to yahoo.com. It uses the Office 365 will receive that email using the inbound type connector on-premises, and it will route that email to external using the without any additional configuration. External sending an on-premises, since the MX is pointing to EOP, it is again received by Office 365, and using the outbound connector of type on-premises from Office 365, it redirects that email to your on-premises server. And on-premises to external domain, Office 365 receives it first, and from there it uses the outbound type connector to send it to Office additional other external Office 365 domain. And how external sending an email is received to on-premises, the inbound type connector of type partner comes into play to receive the Office 365 to receive that email. And from Office 365, it uses the same outbound connector of type on-premises to send that email back to on-premises. On-prem to cloud, no other special configuration. It just uses the default hybrid connectors. Cloud to on-prem, again, the default hybrid connectors. Out to external, the default outbound connector of type partner. Since it is a centralized mail routing, the email is routed to on-premises. And since I said we are utilizing the EOP for complete inbound and outbound, this example is intentionally kept to receive that email back to Office 365. And from Office 365, it uses the outbound connector of type partner to external Office 365 domain. Now, cloud to external doesn't require additional configuration, which again, since the centralized mail routing is enabled, it reaches the on-premises, comes back to Office 365, and it gets routed back to your on-premise external yahoo.com or any other service providers. Now, yahoo.com to cloud, it just uses the default configuration. No other additional settings is required. And then it comes to on-premises. Since we have the centralized mail routing, from on-premises, all your spam filtering or for whatever reason that we have enabled the centralized mail transport, it does that task and it redirects that email back to your Office 365 mailbox. External to cloud, it again uses the inbound connector of type partner, sends the email to on-premises to do its task, and redirects that email back to Office 365. So this is how it works when we have a centralized mail routing enabled, the different connectors involved in different scenarios. Now, the same routing scenario when we have a third-party service provider. On-prem sending an email to yahoo.com reaches the EOP. From EOP, it reaches to external yahoo.com. And yahoo.com replying back to on-premises, it reaches to your service provider, not to EOP. In previous slides, we saw the email is routed to Office 365 because MX is pointing to EOP. Here, the emails are redirected to your service provider. And from service provider, we have an inbound type connector of type partner, which receives an email from the service provider or from the MX or the host, and then it redirects that email to your on-premises mailbox. Now, on-premises to external Office 365 domain. Office 365 domain receives first, and using the outbound outbound connector of type partner, it routes that email to your external Office 365. And replying back to that, it reaches your service provider, routes that email to your Office 365 EOP, and from your Office 365 Exchange Protection, it reaches to your on-premises. On-prem to cloud, no special configuration. It just uses the default hybrid connector. Cloud to on-prem, the same. The default hybrid connector is used. Cloud to external chase, it uses the outbound connector of type partner, and it sends to the destination. And cloud to external Yahoo, it just uses a default configuration of the default outbound connector. External Yahoo to your cloud, again, it reaches to your service provider, and from service provider, it reaches to your EOP. From external Office 365 domain to your cloud, it just reaches your service provider first, and from service provider, it reaches to your Office 365 mailbox using your inbound inbound connector of type partner. So we just saw how connectors comes into play. What are the different types of connectors and when they will be used under different scenarios. We'll just move on to see what are the few basic troubleshooting tools, or what are the methods that we can use to identify what is happening with a specific email or a set of emails. So first important thing is in India. In case if you when anyone's when the recipient or the sender sends raises a concern whether sent or the received email is not being delivered properly. The first thing is the question is about do we even receive any India to start with? And if we have an India, that gives us a basic information about what could be possibly happening during the transit. Okay, if I don't have an India, so what are the next steps? We can do a message trace using the portal, using the Exchange Admin Center, or using a Security and Complaint Center, or using the PowerShell. Okay, so now other tools that we can identify why the email has been moved to a junk, or why it was moved to a quarantine folder, or if the email was received by a different recipient rather than intended recipients. Everything we can try to analyze using the message headers. We can analyze this message headers using EXRCA. That is one of the tools that we can use to analyze the complete message headers. And if we are in an SMTP relay scenario, if you're not receiving an email sent by the relay server, or if we are in an on-premises coexistence, if you're on-premises to hybrid, or hybrid to on-premises to Exchange Online, or Exchange Online to on-premises, it's not working. We can get the protocol logging and see what could be possibly going wrong within that transit. And if the user is not even able to send out an email, or if there are any issues in accessing the client, we can use a SARA or OffCat information to see what is probably wrong with the main client, whatever the user is using to send out that email. NDRs will give you useful information, which will be the starting point of troubleshooting. Like in case if you have an NDR, you possibly know what is going wrong. When we explained the slide for Exchange inbound connection, we talked about DBEB, so that if the recipient server is rejecting that particular email because of the directory-based edge blocking, NDR will clearly give you the indication, or NDR can even give you the information about who is actually rejecting that email. Is it the source, the intermediate devices which you have is not able to relay that emails over to your destination, or is the actual destination rejecting that email for some reason? And if we can also see if there's a single user issue, or it could be because even because of your invalid nickname cache or an outdated information in your offline address book, possibly also causing this issue where you might be thinking you're trying to send an email to the same recipient which you used to send, but there has been some changes in the gal which is not reflecting in your offline address book, or if it is reflecting but you're using the old nickname cache. That is also one of the probable reason why you might receive an NDR, or the internet recipient is not receiving that email. Or the scenarios Office 365 may be blocking because of the following scenarios. First one will be the tenant might have exceeded the threshold, because this normally happens during a relay, or if you're using your service for a bulk or a marketing emails, where we identify the amount of a percentage of emails that were sent from your organization is treated as spam or suspicious. We block that tenant from sending out further emails. You can receive this NDR using this error code. Access denied, ban sending IP. If your IP reputation is not good, or whatever the IP that you're sending out is having a bad reputation within the filtering service, or within the watch that we have here, either use in the spam house or in the internal list that we have. In case if we find that has been throttled, or if it is having a bad reputation, we will reject those emails. This has an end users or the admins can go ahead and request for delisting of IPs themselves using the center.office.com portal. We can just justify what probably went wrong and what actions has been taken to correct it. And once you request for delisting, we will normally go ahead and delist that IP. But if we see the same kind of traffic coming from these IPs, we will start to block these IPs again in the ban sender. The same, instead of IP, if a user was identified as a suspicious user, maybe because of account compromise or be it any other reason, intentionally using for sending out some marketing or any other emails, which EOP cannot be used as a relay service. In that scenarios, we might get this NDR about access denied and banned senders. These are quite some examples. There is a link that will be available within this PPT where it will give you the complete list of NDRs and what they. It will be a starting point of reference for you to understand where to start the troubleshooting from. So again, the same unblocked your IP addresses. You can remove a user from a domain or IP blacklist using the center.office.com, or you can even submit that as false positives or false negative using the support the security and compliance center portal. So how do we track messages in Office 365? Or when do we even try to do this? When we have emails missing, which we discussed, or if there is a delay in receiving emails, to understand what happened or which are the hops which were involved and where the delay was actually happening. The message trace will help us to understand that. And if there is an email that wasn't deleted by a transport rule or a DLP or a malware filter or any other Exchange Online Protection components that you have, when a message is usually quarantined, message trace will help us to identify what happened, the redirected, forwarded, or a message if the message is modified by transport tool. These are certain examples which you can identify the reasons for these using a message trace. And how long is a message trace report available for my tenant? It is only for 90 days. Beyond that, we do not preserve the audit logs for this message trace. Different ways of doing a message trace using the GUI, Exchange Admin Center or your Security and Compliance Center. Main flow, you can do the message trace from there, or you can use the PowerShell to get the information about what has happened. And you can export that even to a CSV if you need to analyze what probably went wrong or what was happening during that particular transit of that particular email. Just an example of a message which has been dropped by a transport rule. You can see the transport rule, the event says transport rule, and the email was rejected by this transport rule, depending upon the action that was specified on the transport rule. It could be any policy with an action which was defined to delete the transport rule has acted on this particular email and it was deleted. This is just an example of what is a PowerShell commandlet that is used for historical search, which is nothing called as extended message trace. When you do a transport normal message trace, the information that you see is just this one. There was a submit event and the email was received by the EOP server. And what happened on that email? It just give you the basic overview of what happened during the transit. But if you want to understand what all components were involved, what are the different actions that happened, all this detailed information from the point where the email was sent till the email was received, if it is within the organization, everything will be captured in the historical search. And to run an historical search, you just need to use the start historical search with message trace detail as a report type. This is the PowerShell way of doing it. Or if you just go to your Exchange Admin Center or Security and Compliance Center, enable the option detail message trace, which will give you the information. It will take, it's not an instant report that you'll be getting as soon as you go ahead and initiate this commandlet or using the portal. It will take some time to generate the report and it will be sent to the respective recipient if you have specified address in the notify address tab, or on the portal. If you just go back to the same trace that you initiated, it will give you an option to download the specific report. This is how an EMT will look like, or an external message trace will look like. So what we'll be normally looking into is the event detail, which will tell you event ID, which will tell you what happened on the particular email. Was it received? Was it delivered? Or was it being redirected to a third party? Those information will be displayed there. But to understand what more on what we will be looking into EMT, let's see further. If you look into this one, there is a column called as AMA equal to SUM, which indicates the number of malware that it was trying to identify. So this was a clean email. If there has been any kind of malware or any other spam detected on this particular email, you will be seeing that V equal to 1, or that V equal to 1 column specifies what were the number of emails, or what were the was there any kind of malicious information or attachments that was being sent using this particular email. If that is yes, it will increase the count of how many um, um, attachments or how many emails were identified as malicious on this one. Now you can see here we have EV, which calls engine, the engine M, the engine A, which is highlighted here, engine K. These are the malware engines which we were discussing earlier. We will be relying on three malware engines normally. So these are the malware engines which is being displayed, and if if either of these engines identify the specific email as a malicious one, it will be treated as malicious or malware. And depending upon the malware action that has been specified on the Exchange Online Protection, it will take actions either to quarantine or to delete that particular email. The other thing that we'll be looking into is SFE equal to SKA. This parameter helps us identify message was skipped for filtering and was delivered to the inbox because there was an allowed list in the spam filter policy. It's basically an allowed list. It acted on this particular email, and it was skipping the um, spam filtering, and it was delivering that email to the respective intended recipient. SCL equal to -1. We have scores of SCL equal to -1, 0, 1, and 5, 6, 7. 5, 6, 8, and 9. So the -1 and 1 normally refers to non-spam emails. The 0 and um, um, the 8 and 9 will highly represent your high confidence phishing or spam emails, and 5 and 6 represents your low confidence spam. Depending upon what is configured in your spam filter policy for high confidence and low confidence spam, the actions will be taken and the email will be sent to the respective location, either to inbox or quarantine or to your junk folder. Now, we talked about how to analyze message trees and EMT. We can also understand, we'll also look into the message headers, and we'll see what are the information that this particular headers are going to give us. So SPF is something that we'll be looking into. SPF is nothing but your sender policy framework, which explains if the sender is a designated sender to send using that specific IP or using that specific domain from where the email has been received. Your TLS will represent the email was sent using an encrypted or from a secure score. Received headers basically indicates where the email has been originated from. And you can see there are, we call it at P1 and P2 headers. Mail from is what is the actual sender information, and your from is where what you see on your the display name on your when for the received email in your Outlook or in Outlook web access. DKIM, these are some to encrypt the email that has been sent using your sending domain, and it will validate if the signature is kept intact during the transit. If yes, we'll be having a DKIM pass signature. If not, if there has been any additional hops that was involved during the transit, that header will be broken, and we might see fail, or will be see something as none if it has not been configured. Other headers, you can see something called as received by, which is the originating client from where the email has been sent. And you can see the in reply to address. This is the header which gives us an information about which email ID or which the message ID it has been in reply to. And if there has been any additional email threads that has been going on and been added to this thread, it will give under the references tab. So we talked about P1 and P2 headers. Whatever you see from your display name is your from address, which might not be the same from what the user is actually sending it from. The directionality, the message directionality header gives us an information about if it is an incoming email or it is an outgoing, or what is did we receive or are we even sending that email from. The content type defines what is a message format it was used to send out that email, and AV stamp, which will see if what are the different types of antivirus engine that has been acted on this particular email. So SEL values, one, which we discussed, -1 and 1 are non-spam emails. It will show us NSPMs if the email is treated as quarantine, or if it has been moved to a spam folder, it will give as SPM or HSPM, which is nothing but spam and high spam. And if we have an email treated as a spoof, it will have a category called as SPOOF, spoof. And if the email is treated as phish, the category of that email which you can determine from headers is PHSH phish. So in a hybrid mail flow, we discussed like it should be the auth as should be internal to preserve your coexistence scenarios. If it is not internal, the auth as will show as anonymous, which means it has been received from internet or from a different source. The latency is what it will give us an information on what was the time taken for that email to be get delivered, the transit time. So EXRCA, once you paste the headers on this particular tool, it will analyze this report and it will give you more informational thing what needs to be looked into. And depending upon what we're troubleshooting, depending upon what we're trying to investigate, we just need to see what are the headers, what are the header fields that we're interested in, and that will give us an information, a potential information about what could have possibly went wrong on this particular email. Protocol logging is nothing but the SMTP logging that should be enabled. If you're in a hybrid scenario, when you're unable to send when you're unable to relay, or when you're unable to send an email from your on-premises to Office 365, once you enable the protocol logging, it will give you the information about what is happening during the transit. It's basically telnet sessions which will give you information about what are the different verbs or what is the server and the client communicating. So here you can see it's written as MIME, which means it is trying to um, send an email using the MIME format, and it is using a star TLS, which means it is trying to encrypt that particular session that has been initiated. And there is a certificate handshake that is happening for your TLS connection. So you can see the sender OK, which means the sender from which you are trying to send is a valid sender, and the recipient is also a valid recipient. And if your connection is successful, you can see the queued mail for delivery. At this point, you can confirm that email has been submitted to the recipient server from your sending server. So what are the different ways that we can troubleshoot mail flow issues? First thing, yes, we need to verify if the required port over which we are trying to send that email has been enabled, or if it was working fine. And if it has stopped working, probably we just need to see if there has been any changes or any other third-party interferences on that particular machine from where it is getting routed is blocking that connection. If you're unable to send an email using Outlook, Outlook Web Access, to see if it is an issue with your client or is it an actual issue with your the mailbox itself. If you're using if you're using a protocols like POP or IMAP to connect using your mailbox, you can just enable the Outlook logging. It is also valid for your normal connection as well, in case if you're having issues in sending out, you can enable the Outlook logging, and we can see what could be possibly stopping us from sending that email using that particular client. Fiddler is one of the trees to see what are the network transitions that is happening between the during the transit or during that particular session. Sarah, to understand if there is an issue with your main clients, the Office clients itself, causing this issue related to mail flow. And Offcat is another which is now integrated with Sarah. So once you get the Sarah report, it will give you probable reasons why or what could be possibly be wrong with the client which is trying to submit that email. So this link will help you understand how to scan Outlook by using the Sarah tool. What are the different methods or what are the different options that are available to diagnose the client issue. So display name, on the previous slides we talked about when we receive an email within the organization or in a hybrid, in a coexistence, we normally see the display name for internal emails, and we see the email address for an email which is received from the external domain. So if the auth as is not showing as internal when you analyze the headers, which means this particular transit or whatever the email that we have received is not treated as an internal email, but treated as an anonymous or an external email, which could be one of the reasons why your display name is showing in, why the email address is showing in the from fill instead of your display name. Now, this normally happens if there is a issue between the connectors, the hybrid on-premises connectors. So we just need to make sure the TLS is set up correctly, and we are having the proper certificate in transit during that session. If not, there are probabilities where we might not be seeing an auth as internal for an internal communication. Again, the protocol logging will help us understand what could have probably went wrong during the transit. What was a handshake that was happening for that particular email transition, and we can try to isolate if that is something which is if any settings has been modified which is causing this issue. Rerun the hybrid wizard, one of the easiest way to see if there has been, normally this happens when there is an expired certificate, and if we do not have the proper certificate in the right connectors, this could probably happen. But rerunning the hybrid wizard with the right certificate probably will help us resolve this issue. So emails, what do we do when we receive emails from an external users and that is being delivered to the junk folder of the recipient? So check the junk email configuration of that particular recipient and see if these particular users are in block senders, or if they trust only the contacts which they have in their mailbox. If that is one of the reasons, yes, any email that is coming from external domain or whatever the users are at, or the domains which are in the block domains or senders will be treated as junk. If the junk email configuration is even enabled or not, it might be showing as disabled when you run the get-mailbox junk configuration. That could also be one of the reason. Check the SCL values, and 529, which we talked about, as considered as spam or high spam. And if these are considered as spam, depending upon your settings, the spam filter settings, it might have been redirected that email to junk folder. Again, the same message headers, what we look into, spam or fish, are the categories of that email. If these are spam or fish, we need to look into the spam filter policy or the fish filter policy that we have and see what are the configurations, what are the settings that we have configured on those respective policies. SFE values, spam, bulk, safe senders, SKB, block senders. Sorry, the BLK is the block. It is in the block list. Category spoof and fish. These are something which we can get from the headers on the anti-spam report. And other reason why the email could be going into a junk folder is because of the content of that email. Probable URLs on that email or probable signatures might be redirecting us to a different website altogether or different URL altogether, which might be malicious, or which we may think it is a malicious or it's not a reputed URL, and we might be treating those emails as junk. So basically, what happens is we need to verify if the senders are on the block list, or the domains are on the block list, or if there is any other transport rules, or if the email has been treated as spam or high spam. These are the reasons why an email could move into a junk folder if it is an legitimate email. Garbled text. It could be a client issue. The sender might have sent it properly, but when the recipient received it, it could be a client issue which is not able to render that email in the right format, or uh, probably a different device on which the mailbox is configured is causing this email not to look in the right way. Or you can also enable the mailbox auditing to see which client actually is acting, or which client is actually modifying this particular item to not display the right way. How to validate delays in sending emails, sending or receiving emails. Now it depends upon who is impacted. Like, is it an Office 365 users who is actually seeing delays in receiving emails, or the external users who is facing issues in receiving the emails in a delayed format? As I showed you, the end-to-end latency on the message headers will give you information on how long it took for the email to be in transit. And but there will be a question, like we can see there are the sending hop and the connecting hop, but it says there is a delay, but we might not be able to get the information who was actually causing the delay. In this scenarios, what will help us is the protocol logging from the sending end, which will give us information about at what time it actually submitted that email and what time the recipient accepted that email. And this protocol logging will help us analyze where the actual delay was happening. Is it from the sender end, or is it from the recipient end? And a normal message trace also will give us information at what time the email was submitted and what time the email was actually communicated or transited to the recipient domain. DBEB, getting an email, getting an NDR because of DBEB. It is because there was a newly created user who is not replicated over to the Azure, or the Azure Active Directory, or a dynamic distribution group, or mail enabled public folders by default will not be accepted using DBEB. In those scenarios, either we need to have the accepted domain as an internal relay, so that the domain to which it is received is not rejecting at first place, but it will try to see if there is an alternate recipient where it can redirect that email to. If it has been blocked by an Exchange Online Protection, or the edge server, or the front end server, perimeter message trace will give information what happened during the initial contact for that session, for that mail delivery. So that is what we had for you today, and I hope this session was useful.